Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to solve logarithmic equations. In each case we have a logarithm on one side equal to a number or an expression on the other, and the way that we're going to solve them is by converting them to exponential form. So a quick reminder, if logarithmic form looks like this, log base a of x equals y. Its exponential form is a to the y power equals x. And so we're going to make that change first, and then we're going to try to solve the equation that we have using the tools that we already know about. So for a, I'm going to take the base and raise it to the exponent on the other side. X to the negative 2 power equals 25 over 49. Now, I can see that my exponent on the left side is negative 2. I would like to write that expression on the right side with an exponent of negative 2 as well, and then I'll have everything solved. What I do know is that 25 is 5 squared and 49 is 7 squared, so I can rewrite this right-hand side as 5/7 to the second power. The exponents aren't the same yet, but I now have an idea that if I want to make that exponent a negative 2, all I have to do is invert the fraction. And so now I get x to the negative 2 equals 7/5 to the negative 2 power. And since the exponents are equal, the only way this can be is if the two bases are the same, and we end up with x equals 7/5. For the second one, we'll start again by converting it to exponential form. So I've got log base 32 of x equals 4/5. That becomes 32 raised to the 4/5 power equals x. I've already got x isolated. All I need to do here is figure out what 32 to the 4/5 power is. Remember, the numerator for a rational exponent, that is the power, and the denominator in the rational exponent is the root we're taking. And I'm going to start with x equals the 5th root of 32 raised to the 4th power. Now I can only do this if I know the 5th root of 32, otherwise I'm not helping myself out at all. But I do know that 32 is 2 to the 5th. So the 5th root of 32 is 2. So I have x equals 2 to the 4th power, and I can do that arithmetic. 2 to the 4th power is 16. I could also have raised 32 to the 4th power first, which is a pretty big number, and then try to figure out the 5th root of that. This was more efficient. One to go here. We've got log base 81 of the square root of 3 equals x. So we'll start by changing it to exponential form. 81 to the x power equals the square root of 3. Now the square root of 3 I can rewrite as 3 to the 1/2 power. If I can get 81 to be written with a base of 3, then I can set the exponents equal to each other. And I know that 81 is 3 to the 4th power. So I have 3 to the 4th power raised to the x power equals 3 to the 1/2 power. I can multiply those exponents on the left-hand side, and I have 3 to the 4x power equals 3 to the 1/2 power. Since the bases are the same, the only way these two sides can be equal to each other is if the exponents are the same. And so 4x is equal to 1/2. Divide both sides by 4, and we end up with x equals 1/8. So there's a quick beginning with solving logarithmic equations. We're going to get into some that are not as easy to solve. They'll require several strategies to make them work, but we'll see that in a later section.